Good morning, everyone, and welcome to this lecture. This is lecture number 10, and we are dealing with the motion of a charge in a magnetic field. In the previous class, we had seen that the motion of a charge inside a magnetic field depends on the angle between the magnetic field and the charge. If the angle is 0 or 180, the force is 0 and the particle continues on its path, nothing happens. If the angle is 90 degrees, we had seen that the force was maximum. This force keeps on changing its direction, but it remains constant in magnitude. The velocity keeps on changing its direction. It remains constant in magnitude. The acceleration keeps on changing its direction. It is constant in magnitude. This force and acceleration are directed towards the center, and we have the case of a uniform circular motion. Whenever we have the case of uniform circular motion, we have to think about the radius of the path, the time period, and omega. Radius of the path was mv by qb, as you can see on your screens. Time period is qb 2 pi by omega. Omega is qb by m. Time period becomes 2 pi m by qb. This time period does not depend on the velocity or the speed of the particle. Then we had seen the comparison between the radius of proton and an alpha particle. Remember, if the mass of the proton is m, mass of the alpha particle, which is helium nucleus, will be 4 times m. If the charge on the proton is P, which is equal to 2e, the charge on the alpha particle will be 4e. Do you understand this? Yes or no? I think I have made a mistake here. Charge of a proton is E, which is same as the charge of a proton is P, which is same as the charge of an electron. It is positive. The charge of an alpha particle will be 2 times of E, or 2 times the charge of a proton. I think I have just miswritten it. Okay, so just correct it. Charge of a proton is E or P, and charge of a helium nucleus is 2E or 2P. Then we had seen if the angle is not 0 or 180, it follows the helical path, and we had seen the radius of the helical path and the time period. The last thing that we saw was Lorentz force. If a particle is under the influence of both electric and magnetic field, the force on the particle is given by the Lorentz force. Now let us start with some questions and finish this topic here. This is the first question that is coming on your screen. A proton and an alpha particle enters a uniform magnetic field with same velocity. Remember, the velocity is same. One is a proton, the other one is a alpha particle. What is the ratio of the paths described by them? And I'll give you 2 minutes to give me the answer. I have an answer of 1:2. That is correct. I have already given it in the table. Still, I will try to solve it. Radius of the path is mv by qb. Here, they enter with the same velocity. The velocity is same. Magnetic field is same. So radius is directly proportional to m by q. From here, you can understand the radius of the proton divided by the radius of the alpha particle will be equal to mass of the proton divided by mass of the alpha particle multiplied by charge of the alpha particle divided by the charge of the proton. Mass of the proton, if I can take, mass of the proton will be m, mass of the alpha particle will be 4 times m, charge of the alpha particle is 2p, charge of the proton is p, and directly you will get the ratio as 1 is to 2. Do we understand this, everyone? 1 is to 2 is the answer. This is, I've already given them as a standard result so that you can get the answer straight away. Let us welcome the next question. And this is the next question that is coming up. An electron and a proton enter a magnetic field perpendicularly. Both have the same kinetic energy. Remember, they have the same kinetic energy. Which of the following is true? I'll give you 2 minutes to give me the answer. So, how are you supposed to do this? They enter with the same energy. Sometimes they call it kinetic energy, sometimes they will simply call it energy. Don't get confused. Both terms mean similar things. So, radius in terms of energy is given by this formula under root of 2 m k by q into b. I hope you remember this. Now, 2 is same for both. Kinetic energy is same. The charge of an electron and proton are same. One is positive, one is negative. The magnetic field is same. So you can see radius is directly proportional to the mass. So I can say radius of the proton divided by radius of the electron will be equal to root over mass of the proton divided by mass of the electron. Now remember, mass of the proton is very large compared to the mass of the electron. Therefore, radius of the proton will be very large compared to the radius of electron. That means the path of the proton will be less curved. The part of the electron, its radius is more, will be more curved. So the correct option is which one? Radius of the proton is more compared to the radius of the electron. Now can you tell me which option is correct? Option number B, that is correct. Trajectory of proton is less curved. More radius means less curve. Less radius means more curved. So that is how we see it. Let us move on to the next question. This is the next question coming on your screens now. A proton of mass m and charge plus e is moving in a circular orbit of a magnetic field with energy. The kinetic energy or energy is given 1 MeV mega electron volt. What should be the energy of an alpha particle? As I said, mass of alpha particle, which is helium nucleus, is 4 times the mass of the proton, and charge is 2 times the electron or 2 times the proton, so that it can revolve in a path of same radius. I'll give you 2 minutes to give me the answer. Think aram se, take your time, solve the question and try to get the correct answer. So let me solve it for you. 1 mega electron volt, that is correct, beta. Radius, if I write in terms of kinetic energy or energy, root over 2mk by qb. Now, what all things are same here? The radius has to be same. The magnetic field has to be same. So from there you can write kinetic energy of alpha particle divided by the kinetic energy of the proton will be equal to Q of alpha particle divided by Q of proton squared multiplied by mass of the proton divided by mass of the alpha particle. Now, charge of the alpha particle divided by charge of the proton will be 2. 2 square will be 4. 4 multiplied by mass of the proton divided by mass of the alpha particle is 1 by 4. So the ratio is 1. So both the kinetic energies have to be same, and therefore the only answer that matches is 1 mega electron volt, and that is the answer for this question. Have we understood this? Yes or no? No or yes? Well done. Again comes the next question, and I'll give you enough time, sufficient time for you to solve it. 2 minutes, 3 minutes. This is the question. A proton and an alpha particle same enter a magnetic field perpendicularly with the same speed. The proton takes 25 microseconds to make 5 revolutions. What is the time for alpha particle? I'll give you time to solve it and give me the answer. Think correctly and give me the correct answer. So how are you supposed to do this, beta? The proton takes 25 microseconds to make 5 revolutions. From here, I can find out the time period. In 25 microseconds, it takes 5 revolutions. Time taken for 1 revolution will be the time period. For 5 revolutions, it takes 25 microseconds. So time period becomes 5 seconds. This is the time period of the proton. Now you must remember time period is 2 pi m by qb. 2 pi m by qb. 2 and pi are same. Magnetic field is same. So I can now write time period of the alpha particle, which we have to find out, divided by time period of the proton, which is given to you, will be equal to mass of the alpha particle divided by mass of the proton multiplied by charge of the proton divided by the charge of the alpha particle. Mass of the alpha particle divided by mass of the proton will be 4. Charge of the alpha particle divided by the charge of proton would be 1 by 2. So this ratio becomes 2. So the time period for alpha particle will become 2 times the time period of the proton. The proton time period is 5 seconds. 2 into 5, 10 seconds. And that is your answer. Do we understand this, everyone? I'll give you 2 minutes to note this down. Till that time, I move on to the next question. I hope we have understood this. Okay, let us move on to the next question. The more the number of questions that we solve, the better are we going to perform, and you can have one question coming from this part definitely. This is the next question. A particle with 10 raised to the power minus 11 coulomb of charge and 10 raised to the power minus 7 kg mass is moving with a velocity 10 raised to the power 8 meter per second along y-axis. It's quite a huge velocity. A uniform magnetic field 0.5 Tesla is acting along the x direction. What is the force on the particle? There are 4 options given to you, and I'll wait for you to give me the correct answer. So how are we supposed to do this? You can straight away apply the formula. F vector is Q V cross B in this particular case. Once you apply this formula, your F vector will become Q is positive charge 10 raised to the power minus 11. Velocity is, as you can see, 10 meter per second along y-axis. So you can write it as 10 raised to the power 8 J cross. Magnetic field is given as 0.5 Tesla, 0.5 Tesla along x-axis. So you can write it as 0.5 I hat. You can just take the cross product. J cross I is minus K, and if you multiply, you will get 5 into 10 raised to the power of minus 4 along minus K. J cross I is minus K, and then you can multiply all these things and you will end up with option D, 5 into 10 raised to the power minus 4 Newton along minus K. I'll give you 2 minutes to note it down. Everyone is noting this down. Okay, so let us move to the next question. And this is the next question. An electron is moving along positive x-axis. To get it move in an anti-clockwise circular path in the xy plane, magnetic field should be in which direction? I'll give you 2 minutes to give me the answer for this one, beta. So how are we supposed to solve this? Remember, an electron is moving like this along x-axis, and you want to move this in a anti-clockwise direction. Now, if you want to move it in anti-clockwise direction, how it can move? It can move like this in the xy plane, or it can move like this in a circular path. How you want to turn it? You cannot turn it on the lower path because that will be clockwise. So you have to turn it on the upper side like this. Now, to turn it on the upper side, if I take the cross product of V with B, if I imagine that magnetic field is in the inward direction, V cross B gives me the force in the upward direction, but that is the force on a positive charge. So if this charge was positive, if you put the magnetic field inside, it will go upwards, but this is a negative charge. So if I put the magnetic field inside, it will go downwards. So magnetic field cannot be inside. So that is the wrong option. The only other option that is correct would be if you put the magnetic field outside, V, and magnetic field is coming out, positive charge will move downwards. That means negative charge will move upwards. So the only correct option is the magnetic field must be along positive Z axis. Do we understand this? Yes or no? No, yes. Great. This is how you can find it out. One or two more questions based on this so that you understand how this is done. In a certain place, magnetic field is vertically downwards. An electron is approaching horizontally towards you, enters this magnetic field. Its trajectory, when seen from above, will be a circle, which would be how? Now, such type of question, you have to imagine how they are done. I will help you out in imagining this. Magnetic field is vertically downwards. So let me call this magnetic field vertically downwards. Electron is coming towards you like this. So the velocity of electron is like this. Remember, it is an electron. Now you have to tell me how it is going to move in the circle. You have 2 minutes to give me the answer. And I have the answer vertical clockwise, that is correct. V is outside, B is downwards, V is outside, B is downwards. So the force will be like this. The force would be like this. The force would be like this. So it will start to rotate in this circle. But remember, it's an electron. It's an electron. So this is the force on a proton. So I'll just write, this is the force if this was a positive charge. For an electron, the force would be like this. Force would be like this. So it will move like this. This is the force on an electron. So if you look from the top, it will be moving like this. It will be moving in the clockwise sense from the top, and therefore the answer is horizontal clockwise. Remember, such questions may be difficult to imagine, but they can give you such questions because it's just about imagination. If you can put your imagination correctly, you should be able to solve such questions very, very simply. Comes the next one. When a charged particle circulates, moves in a magnetic field, then the area of its circulation, okay, area of its circulation is proportional to what? I'll give you 2 minutes to give me the answer for this one. And the answer is indeed kinetic energy. The concept is very simple. R is mv by qb. You can also write it as 2 pi m, sorry, root over 2 pi 2 mk by qb. Now, if I talk about area of the circle, it will be pi r square. So it will be pi into m square v square by qb, or it will be equal to pi into 2mk by q square b square. Now you can see what is this area proportional to. It is definitely not directly proportional to momentum. It is momentum squared. Magnetic field intensity, it is inversely proportional to 1 by b square. You can see it here. 1 by b square is definitely not directly proportional to charge. It's inversely proportional to 1 by charge square. The only answer is kinetic energy. So that is how you find this one. I hope all of us understand this. This is again a question taken from your previous years. The question comes, and these are the type of questions that are coming in the exam these days. I'll give you a minute to think about this. A magnetic field is downward perpendicular to the plane of the paper and few charges are projected in which of the following is true. You can see both are moving in curved path like this. Now the initial velocity in this direction, V cross B, force is upwards. Force on positive charge would be upwards. Both of the bodies are moving upwards. Therefore, both of them would be positive charge. So this option is definitely wrong. This option is definitely wrong. You just have to see who has more velocity. R is equal to mv by qb. So radius is directly proportional to velocity. The particle which has more velocity will have more radius. Which has the more radius? Radius of B. As you can see, radius of B is more than radius of A. So the speed of B will be more than the speed of A, and therefore the correct option happens to be option C. Option C, my dear friends. Do we get this? Yes or no? No, yes. Option C, my dear friends, is the correct answer. And that is the one we are looking at. Anyone understood this? Yes or no? No, yes. Okay. So that takes us to the end of this class, beta. And this class, we have covered all the types of questions that were possible in your magnetic force and motion of the charged particle in a magnetic field. Remember, when the angle is 0 or 180 degrees, the force is 0, there is no force acting, and the particle will continue its original motion. The interesting case happens on which 100% of the question, 99.9% of the questions are going to come. It's the case where the B magnetic field and V velocity are perpendicular to each other. In that case, the force is maximum, keeps on changing in direction but not in magnitude, and the particle moves in circular path. R is equal to mb by qb. The third case, which will rarely come, is the case where you have what? You have a particle moving at an angle which is not 0 or 180. It is between 0 and 90, or between 0 and 180, or 90 and 180, whatever. Acute angle or obtuse angle, not 0 or 90 or 180. In that case, it follows the path of an helix. It rotates in circle and it also moves forward. Everyone remembers this? Everyone understands this? Yes or no? Okay, that's great. So I'll wind up this class. In the next class, we'll be moving ahead with the last part of this chapter, which is force on a wire. So I'll see you in the next class. Take care. God bless all of you. Bye bye. If you have any doubts, you can always come up.